Good day, ladies and gentlemen. This is Sarah van Gr12, aka Mr. VG, on this cold winter morning, and I am excited to do this specific sum with you, looking back at your exam 2021 mathematics, specifically the financial mathematics section. I broke question 8 into two parts, 8.1 and 8.2, and then 8.3. That is going to be on the next video. But 8.1 and 8.2 I specifically want to do with you all because it basically is mostly grade 11 work, but actually it's going to incorporate some grade 12 knowledge. So as you prepare this for financial mathematics, understand that we are going to ask two types of questions. We're going to ask some grade 11 or 8 to 11 work, grade 8 to 11 work, and then we're going to ask some grade 12 work, of course. So what I'm going to encourage you to do is do the sum. Do these two sums, 8.1 and 8.2. Hit the pause button if you haven't done it yet, then continue with the rest of the video, and then I'm going to explain to you the thinking that goes on behind 8.1 and 8.2. So when we look at question 8.1, I actually want to not look at 8.1 first. I first want to take a step back and remind you about something that I call the decision tree. I love decision trees, ladies and gentlemen. I love it, love it, love it. Because decision trees just help me to eliminate, the things I want away from the things I don't need at all, okay? So in financial mathematics, I did a whole video on the decision tree, but I still want to go through the decision tree with you so you understand the logic of what goes on in this sum. So in a decision tree, the first question I want to ask in financial mathematics is how many payments do you make? Either you are going to make a once-off payment or purchase, or I'm going to make periodic payments. Now, when we talk about periodic payments, it's payments that are exactly the same every month, every quarter, every year. So when we look at once-off payments, I have to ask myself, once-off payments or purchases, is it a growth that's happening or is it a depreciation? If it is growth that's happening, I've got growth split in two. Either I can have simple growth, where I use the simple interest formula, or I could use compound growth, and that is a compound formula. Now, for compound growth, remember that includes things like population growth. It also includes inflation, is all part of that. But when I look at depreciation, depreciation can either be on a straight line method, where I use almost a simple growth but with a minus, or it could happen at reducing balance method, where I use compound growth but with a minus in the bracket. Now, periodic is your grade 12 work. Now, periodic payments, I have one of two choices, okay? When do you want the money? Okay, when do you want the money? Do you want the money at the beginning? Then I'm going to use the present value formula. That's like I want to take out a home loan. But when do I want to buy the house? I want to buy the house now. Or I want the money at the end. I invest money for 5 or 10 years. Then I'm going to use the future value formula. Okay? So this is the basic decision tree you have to think, because one of the biggest issues I've seen in all of financial mathematics is that students use the wrong formula. If you use the wrong formula, ladies and gents, 1 mark max. That's the reality. So you have to make your decision count. So when we look at question 8.1, it says here a farmer bought a tractor for 980,000. So he buys it now, so that's my present value. It could also be seen as the cost price. The value of the tractor depreciates. So automatically I've got one of two choices, either straight line or I've got reducing balance, one of the two. See how I've eliminated all the other formulas on my formula sheet. Also, they say that there's an interest rate of 9.2%, but some of your teachers would not like to use 9.2%, so you could either use 9.2 over 100 or 0.092. Your choice. You must decide. Please keep your teacher happy. That's a very important thing. So when we look at this, the next thing says reducing balance method. So now I eliminate the first formula and I know I'm stuck with the power of n. The big question that they want to ask now is, calculate the book value of the tractor after 7 years. Okay, so book value, so they're looking for the A, and therefore n is 7. I love to break apart my question like that. So I've got 4 variables, A, P, I, and N. So when I go to my formula, that's always my biggest starting point. I substitute now in what I've got. P is 980,000, I and N. Plonk it in my calculator, and I get 498,685 rand and 82 cents. Ladies and gentlemen, that is the book value. In other words, it is actually the worth of the asset if they wanted to sell it. So understand what this basically means if they had to ask it in a further question. If I want to sell it at book value, it means I make 0 profit. The moment I sell it for over 498,000, I'm going to make a profit from selling this asset. So this could be asked as part of a sinking fund. We love sinking funds. If you are a bit unsure about it, please refer back to my sinking fund sums that I have on the Junior Tikkie online website. Now let's look at question 8.2, because this is now where we're starting to mix grade 11 and grade 12. 8.2, it says, it reads, how many years? So n is the question mark. Automatically my mind starts going towards logarithms. I'm just telling you because that's a lot of times in financial maths that we love to ask. So how many years will it take for an amount to accrue? So I know it's growth, which could be either simple or compound growth. They're giving me the P value, the present value, the starting value, and they give me 2 formulas. Okay? Now, I don't know which formula yet, but they give me the A value as well. So automatically I kind of go, spidey sense is tingling, because they give me the interest rate is 6.8% over 4. So 0.068 over 4. You can put this in your calculator and get a value of, I think it's 0.01. Let me do my maths quickly. 0.017. That could be right. Yes, 0.017. But please don't worry about that. I would literally leave it in fraction form. The reason why I leave it in fraction form, ladies and gentlemen, is what if there's a repetitive like 0.0133333333333. Then you tend to round off, where I don't think you should do that at all. It makes the sum not so accurate. But that interest rate, ladies and gents, also means that is the percentage growth every quarter, because they say quarterly. So that is by how much the 75% or 75,000 Rand will grow every quarter. But embedded in the compounded quarterly, there's also the word compound, which means I'm going to use the compound financial maths formula. So going and writing that out, I've got to remember that N, whatever answer we get, is in quarters. Now, some teachers, some students love to go, "Sir, do we use 4 times N?" I don't like to use that. I just love N. And then in the final answer, we interpret. So I don't like to complicate my life, because the formula, that N that is in your exponent, is the number of quarters, because it's compounded quarterly. So writing out the formula, I'm going to substitute the values in. If I substitute the values in, I now am going to ask myself, what do I need to calculate? I need to calculate N. So first, before I can calculate N, I have to isolate my bracket. So isolating my bracket, I'm going to divide both sides by 75,000, and I get an answer of 1,550, blah, 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 blah. I'm again not going to round that off at all. Remember, in maths, ladies and gents, you only round off in your final answer. Do not round off in the middle. You've got an awesome calculator. Use it. Learn to use it wisely. Now I've got to think. My bracket is isolated, so I've got to now solve N, which means I've got to use logs. Remembering that in logarithms, if I've got a to the n equal to b, and I want to solve for n, remember that n goes on its own, okay? I like to do this. I love to call this the circle method, that the n goes on its own and the b goes into the exponent. If you are unsure about that, please, please, please go and watch the videos on the Junior Techie Online, where I go into a lot of depth in solving N. When looking at this specifically, I can now say, okay, N is equal to log of the base, which is 1 plus 0,068 over 4. And that, so in other words, that N goes on its own, and the 1,55 goes into the log. Now this I can simply put in my calculator, and I find N as being 26,000 something. So even if I round off to 1 or 2 decimals, it gives me 26 what? Quarters. But the question was, how many years? So how am I going to get quarters to years? I'm simply going to divide by 4. So this means that N is 6,5 years. So it's going to take 6.5 years to grow 65,000 to 116,253,50. As simple and as easy as that. Ladies and gentlemen, let's take it and just recap. Always start with a decision tree. Start with which formulas am I going to use. Is it once-off or periodic? Is it growth or depreciation? Is it when do I want the money if it's periodic? Okay. We are going to go and look at this again in the next video. The next video in 8.3, we are specifically going to look at annuities. So tune into our next video and have a beautiful rest of your day. Keep well, keep yourself safe. This is Mr. VG signing out. Cheers.